All right, so we are looking at, I think this is 2.6. We are starting our journey into proofs. So anyways, proofs are sometimes students' favorite thing, or they're like, favorite thing. Ugh. So we'll kind of figure out where you are. When we go to introduce proofs, we're actually going to start with algebra-based things where it's something that you kind of already know how the steps are, and that way you're able to just sort of follow and start getting the notation down with something you're already comfortable with. So I know at first you might be like, okay, I'm proving how to solve an equation. Come on, dude, pre-AP math, I already know how to do this. I know. But it's more to teach you the steps, the kinds of wording and notation. Some of them are going to be pretty self-explanatory. Some of them are like, I've never heard that word before. So it's going to help you kind of get used to that. And then we will slowly build throughout the rest of this week some of the different things we'll do with segments and angles. And eventually we're going to kind of have a proof piece of literally every unit we do all year, where we're going to stop and kind of talk about how the proofs work there. So they're not going to go away. So we do want to get good at them. And it is about being very formal and doing your arguments in a very logical way, right? We're in the logic unit. So some of the things that we're going to look at as far as algebra proofs, we have the kind of algebra steps that you normally do, right? So normally when you're solving problems, sometimes you add stuff to both sides, subtract from both sides, multiply, divide both sides. Sometimes we'll do substitution where like maybe I know x is this, so I will plug that into this equation to find y, like a substitution is a step. We also know about distributive property, where if I see parentheses, I can multiply the number in front into everything within the parentheses. The other one that we're going to use is called simplify, and some teachers will split these up into like combining like terms and order of operations. What I mean by simplify is, let's say I did a substitution step that involved me plugging in like x is 3, and then my next step is, well, the math is 2 times 3 is 6, 6 plus 5 is 11. I would say, what did I do? I simplify that. This would be like doing order of operations. I just kind of did the math that I saw. Because usually, try to think where I was going with this. Really should prepare before I get on my video. But normally when I say something is like multiplication property, it's the fact that I took 1/2 x equals 8, and then I'm allowed to multiply both sides by 2 to help me solve. I'm not calling it multiplication property when I say 2 times 3 is 6. That is just me simplifying that expression. So I want you to be aware when I say like add, subtract, multiply, and divide, it's because we're doing it to both sides of the equal sign, whereas this is just doing math, and that's what I'm going to kind of call simplify. We'll probably see it happen in an example, maybe we'll unweird it there, but those are all the words I expect you to have sort of seen before, and just know that we're going to use them. Another thing I want to point out is that these are called algebra properties of equality. So a lot of times when I write that I added to both sides, you're going to see us write the step as add POE. Like POE, it means property of equality. So if I'm like, hey, baby example, x minus 2 equals 8, and that's where I was given to start my question, and I go, I'm going to add 2 to both sides and get x equals 10. If I was writing this in a proof, I would say the step I did is that I added to both sides, and the POE is just the property of an equal sign that is what lets you be allowed to add 2 to both sides. So just kind of giving you that preview for when we get down here. The vocabulary words that I don't expect you to have seen before are reflexive, symmetric, and transitive. And some of these, you will see them in different uses. Like you won't see reflexive really be used until later this week, because reflexive really just says that I equal myself. And it seems like that's kind of random, but maybe I'm looking at a diagram and part of my proof needs me to refer to maybe an angle or a side length that otherwise has not been stated in the problem. Reflexive kind of allows me to bring that into the conversation. Like, hey, I noticed there's this angle A, and it's really important, I need to talk about it. I can say that angle A is angle A, and the step is called reflexive. And it's basically just a step that says this exists, and now that's on the paper, I can use it. But if that's a little confusing, don't really worry about that too much until we use it in an actual problem, and then you'll see how it shows up. What we will probably start seeing right away is the symmetric property. Symmetric property is the fact that I can turn something around. And in an algebra problem, it'd be like if I got down to the answer is 2 equals x, we all know you can spin that around and say x equals 2. Well, why do we all know that? Because this symmetric property is a fact, that I'm allowed to write it the other way if that's the goal of the question. So that's something that we will see symmetric property. Transitive, it's kind of like law of syllogism that we just did in our laws unit, where it connects things. Like if A is the same thing as B, and B is the same thing as C, then I can connect them and say that A is the same thing as C. And that might seem like a, well, no duh statement, but possibly in a proof, where I'm trying to prove that angle A is equal to, or is congruent to a specific thing, I might know, well, A is congruent to B is in the problem, and B is congruent to C is in the problem, then I'm allowed to connect A goes to C, and I would write transitive as my step. Like it's the one that lets me go, yeah, but you said this one and you said this one, that means they can connect. That's sort of when I make a connection like that. Again, I'm going to say that for the algebra proofs we're doing today, the only one of these three you're going to see probably is symmetric. But again, I'm just introducing some vocab words you're going to see. So let's say I were doing a proof. And in a proof, we do what's called a 2-column proof. I'm not going to make you write like statements and reasons, but the left is like what's going on and the right is my explanation why. So we always start off with the word given because that's what the problem told me. Sometimes the problem will tell me a whole lot of stuff and I might have multiple givens, right? But given is like, here's what you gave me. And so for an algebra problem, you gave me an algebra problem. Now, it's sort of like we're not allowed to skip steps in our head. What's the first thing I would do? I would distribute this and get 2x plus 10 equals 7x minus 5. What did you just do? You distributed, like you just writing down your step. Okay, that's an allowed math step. Now I need to subtract my x's. I can either subtract the 2x this way, keep it positive, or I could subtract it this way, make it negative, your choice. Let's say I subtract the 2x this way. Then 10, once I subtract my 2x, I'm at 5x minus 5. And because I subtracted, we call that subtraction POE. And again, all the ones that are like add, subtract, multiply, divide, you're going to see us write POE next to. The next step is that I want to add this 5 over here and get 15 equals 5x. So what did you do? You added technically to both sides, so that's add POE. The next step is to divide by 5, and I don't want you to flip this around. If you flip it around, that's actually a step we're going to write that we did. So if all I do is divide this, I'm getting 3 equals x, and that's because I divided both sides by something. If at the very end I want to flip this around and say that x equals 3 as my proof, then from here to here, this is an example of one of those properties up here, where I just usually write sim for symmetric. Okay, that's the fact that I'm allowed to spin that around. Now, you don't have to rewrite this, but I want to give you a quick for example. If a different student took this exact same problem, but let's say they chose to subtract their 7x this way. So they got negative 5x plus 10 equals negative 5. They would still write subtraction POE because they did move it to the side by subtracting. This next time they're going to subtract 10 this way and get negative 5x equals negative 15. Subtract POE. So in the last one you notice it ended up being adding because I ended up moving that this way. For this version of it, that is subtraction. So I know it seems silly, but yes, if I added versus subtracting, that's what I'm going to write down. Then I would divide both sides by negative 5 and get x equals 3. So I divided both sides. But this time, I don't have to flip it around based off of that, which means I don't need that symmetric step. So we're not saying that you have to use it, but if you have to flip it, then yes, you have to use symmetric. So it kind of just depends how you went. There might be more than one way, but like I said, just don't like do a step in your head. Literally, it's like step by step by step, here's why. And again, this is building up when we go to prove much more complicated things in our class. We are going to structure it like this. So we're just practicing it on an algebra problem that you clearly know how to do, so you can start getting used to what this type of thing looks like. All right. In your packet, if you have this, it's a couple of pages in. You'll have to sort of flip. You'll see a bunch of algebra properties and stuff. I was going to do a couple of these examples, and then I had them try some at home. So here is just, what did they do? Like, let's say this was my given. It looks like they subtracted the 6x to both sides, so subtraction, property of equality. They then added the 7 to the other side, so add. They then divided by -2. Great, I'm done. Okay, this one, just because it looks a little funny, looks like the first thing that happened, well, of course, it's always given. First thing they did was add 9 to the other side, so add, POE. The next thing I noticed is this fraction went away, so it kind of looks like they did that magic trick I've showed you where you times the whole row by 7. So I would say that they did a multiply, POE, they times everybody by 7. And it doesn't look like they subtracted anything over. It looks like they just took the 7x plus 63 equals y and flip-flopped them, and that's where I put symmetric, that I'm allowed to do that. Okay, so again, not trying to fix the whole world, but I basically had them practice that. So if for any reason you would like to maybe practice these two right now in your packet, you can just pause the video real quick, just to fill them in, just for the practice of it, and I'll just go ahead and give you the two answers to them. So this one is given. I would subtract the 4x over and get 3x minus 11 equals 19. So I subtracted property of equality. And then added 11 to the other side, which is 30. So I added property of equality. Divide both sides by 3 is 10. So I'm dividing both sides of an equal sign, and I'm done. And there's no rule that says you're going to use every blank, or that you might even need more blanks, because sometimes it depends on the direction somebody does their steps. This one, they distributed. So here's my given. We're getting 8x plus, oh my gosh, 44. I was like, I cannot multiply. And that was distributive. So we're not writing multiply POE, because we're not multiplying both sides of the equation by anything. We're just doing this step, which involves multiplication, but it's called the distributive property. And I usually don't write POE, even though I think you can, because I think of POE as something I do to both sides of the equal sign. But I'm not going to be like evil if you included it or didn't in something like that. Here I'm going to subtract 44 and get 32. So I did subtract from both sides. I'm dividing by 8 and getting 4, and I did divide from both sides. There's a couple others if you really wanted to try them. The only thing that didn't happen in these is a symmetric step of needing to spin them around. But maybe it could have. I don't think it would have. But if somebody did choose to subtract the 7x this way, I don't know why they would. That make it negative and yucky. But if they did, then later they would need a symmetric step to spin that around because x is on the right. All right, that's that. So then I wanted to, what we did in class is we practiced just reading random isolated statements and saying what property is this. So is it add, subtract, multiply, divide, distribute, simplify? Or is it that reflexive, symmetric, transitive, where again, the algebra, we only saw symmetric. Reflexive is where I equal myself, and transitive is when it sort of connects. The only other one that we haven't seen used yet today is substitution, and substitution is where I replace one piece with another piece. Sometimes there are questions where you could say it is transitive or substitution, and I'll show you an example that does that, like where like either one could work. But there are certain times when transitive is the only right answer, or when substitution is the only right answer. But there are occasions when it can look like both, depending how you think about it, and both would be accurate. So for example, this first one I actually think does that. If JK is the same thing as PQ, PQ is the same thing as ST, then I could read that forward. JK goes to PQ, and that goes to ST, then I could say JK goes directly to ST. That, as a step, the way I just said it out loud, is called transitive, because it connected all the way across. Okay, that is a completely correct answer. Another student might say, okay, well you told me PQ is the same thing as ST, So I just deleted PQ and stuck ST here. Well, that's what this says. That student would say that this was substitution. And I'd be like, yes. Okay, this is an example where both of those things are technically accurate and I'm fine with them. Something that would have to be transitive is if it connected more than one. Like, so this right here is a single substitution, but if it connected and then connected again and connected again, and I only want to write it as a single statement, that would have to be transitive, that I write it all the way through to the end. All right, just kind of pointing it out there. Most of the rest is pretty straightforward. When I look at this statement and then I look at what happened, it looks like this went +5, that has a +5. Reading this direction, this was an add POE. Like, it was not a helpful step, they just made it look uglier, but they added 5 to both sides. They're allowed to do that based off the addition property or equality. This question, I'm basically taking AB plus AB and the fact that it equals 2AB. I'm literally just adding those things together. I'm like combining like terms. And so I picked this example to remind you that is not add POE. I did not add something to two sides of the equation. I took this and it equaled this. That is what we just call simplify. Again, you could be more specific with your simplify and say that it was from combining like terms or order of operations, but I generally accept simplify when I just literally combined or did some math, but I didn't like do it to two sides to make something go away or make something appear. AB equals AB. Looks like not a lot happening. That is one of those special words, that RST, that R for reflexive, S for symmetric, T for transitive. Reflexive is like when I equal myself. Okay, symmetric, let's see if one of those happens. Yes, this is symmetric, where P is the same thing as Q, Q is the same thing as P, they just flipped it around. That's what we call a symmetric step, whereas I equal myself is a reflexive step. Again, we saw where this shows up in a proof. We haven't really seen why this is helpful yet, but I do want you to start knowing that that's what that's called, so when we need it, you can do it. Here, ST is 2, SU is the same thing as ST plus 3, then SU equals 2 plus 3. So it kind of looks like they just took this ST, because here's my SU and my plus 3. It looks like they just took it and replaced it with 2. And ST does equal 2. They're allowed to do that. This is substitution. This would not be allowed to be transitive because it's not like ST goes to 2 and 2 goes to, like, that didn't work here. It's literally, I removed this, I replaced it, and now it looks like this. That is substitution. But like I said up here earlier, I know I scribbled all over it. Here you could argue that you just replaced PQ with ST and say substitution. You could also, for this one, say JK goes to PQ, PQ goes to ST, so I can skip it to here. That's, again, I know I'm repeating myself, but that's an important distinction, that this is an example when it could be both, versus here is an example when it's just substitution. Here it looks like they multiplied both sides by 3, so multiply POE, okay? So if you would like to check in the packet, there is kind of on the same page. I think it's actually, if you open your book, the ones we just did a minute ago with the algebra, this is over here on the left page. So I just gave them like 2 minutes and said, fill in as many of these as you can between 1 through 15. So if you, again, want to pause the video and do that, I'm just going to write them down. I don't think I'm going to explain them this time, but I will just give you the answers. So reflexive, 1 equals 2, 2 equals 4, then 1 equals 4. I would say this is substitution or transitive. This is symmetric, they flipped it around. STYZ, YZPR. Again, this is substitution or transitive. I forgot to tell you, you could call this subtract POE, like I'm okay with that, but actually there's a complication about that I don't want to get into right now. That I would have actually removed that and told you not to. Okay, 412 equals itself. That's reflexive. Why is that helpful? I don't know. That's the answer. B equals A and B equals 0, then A equals 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. 0. I could probably replace it here and spin it. Like I could call this one substitution. I could probably also call this one transitive if I connected it. Like A goes to B goes to 0, so A goes to 0. I would be okay again with either one. Figure A, again, reflexive. These two angles equal each other. Then the measure, okay, let me find this. So DEF and ABC. Let me find where they're at. DEF and ABC. Looks like it just randomly added an extra angle to both sides, but they're doing it to both sides. That would be add POE. Okay, it'd be like adding 2 to both sides, where it's adding the measure of something specific to both sides. Here they went from here to here, that's divide. POE, they flipped it around, so it's symmetric. Here it looks like they times by 2. If x equals 5 and b equals 5, then x equals b. Again, I would say that you could use substitution or transitive, depending how you're thinking about that. This one, I noticed there's this minus AB that's kind of randomly on both of these. And then at the end, we are just left with this. So I would pretend like in your head, this ends up being add POE, but let me explain why. It's like as if this said like x minus 5 equals y minus 5, and then I just said, let me add 5 to both sides, cancel, cancel. Like they added AB to both sides to make it go away. Like I know it looks like subtraction right now, but I had to do a plus AB to both sides to make it cancel. So that would be adding POE. Lastly, A is B, B is C, A is C. So yes, you can connect that all the way across as transitive. I would also say that you could call this one substitution. All right, where did I put? I think my little, oh, there you go. I'm like, how do I get that back? Okay, let's see. So the next thing that I had them do is kind of in the packet. I don't think we necessarily need to practice this. I don't want to waste your time. But I basically just said, okay, if it is reflexive, what would I write? Like, oh, that's one that equals itself. Or transitive, I want you to find something to connect and kind of write it. The answer key to this notes will be up. If you want to look through it and practice some of those in the packet, you can totally do that. But really, I just want you to go to the homework to practice. That was just sort of what I did in class to kind of use our time together talking about everything. So there's a textbook homework. Remember, you have a quiz coming up on Wednesday. It will include algebra-based proofs for sure. So make sure that you recognize all these properties from today, that you do practice this stuff in the book, and then pull up the answer key to these notes to check that. I would definitely look at that before the quiz. All of that is going to be on there. Also keep in mind any of the vocabulary from the quiz y'all already took. That is of course still fair game because we're in that chapter still. So I would look over the old quiz and I would make sure you know all of this. Heavy, heavy, heavy walking into the quiz on Wednesday. Okay, otherwise, make sure you're working on that chapter worksheet. You've almost got 2 weeks left, but don't let it sneak up on you so you can log on and ask me any questions that you have. All right, guys, have a good one.